Hello viewers and listeners, today we are talking with Professor Francisco Nauber Gois about genetic and computer algorithms. He is currently working as a professor at Fortaleza University, Brazil in AI department. He is teaching several courses in areas of deep learning, software engineering, testing and software development. Also, Nauber did his research in model-based tests and genetic algorithms. He is practitioner and using technologies to build our world better place for all of us. Hello, Nauber. I'm so happy to have you here today, and thank you so much for being with us today.
Yes, I'm happy in be your channel another time. It's great. I love to communicate new things, so thank you for the invite.
Okay, Nauber, my first questions to you are genetic algorithms and computer algorithms similar?
Computer algorithms, somebody create a code, programming a code. Genetic algorithm evolves, so it's different because in genetic algorithms you don't need to code how the genetic gonna work. You need to use a meta risk. Meta risk is how to teach the algorithm how it evolves. So in genetic algorithms, the software have a behavior that is better and better every time. It's like the evolution theory. You have evolution theory where some species evolves to get better in the environment. So genetic algorithm is something like that. The code evolves in environments. She evolves to get better. So it's different for the common code algorithms.
Nauber, could you give me an example of genetic and computer algorithm?
Yes. For example, you have a PlayStation game. You have some persons in basketball game or volleyball game. These persons, for example, it can be a genetic algorithm product. For example, you can get a player. For example, you can get Cristiano Ronaldo player or Michael Jordan player and evolve this player to get better than others. So you get a player to play with each other or to fight with each other. For example, Mortal Kombat. You have two players fighting, and the other is get better and better with genetic algorithms. The common code, you have lines of code. In these lines of code say how the program works. In genetic algorithms, this is different. She can evolve with the reactions of the environments. So you don't need to program everything. The genetic algorithm, the meta risk play the agent, and the agent evolve in the environments that she lives. You can get a player, she evolves to play like Michael Jordan, for example.
Nauber, you already mentioned, but could you describe for me once more how do they work, genetic algorithms and computer algorithms?
In genetic algorithms, you have something like a crossover or mutation. You can have genes, and you program how these genes or crossovers occurs. In the common software, you have line of code. You programming each line, and the interpreter of the software interpreter run line by line, and you have the software behavior. In genetic algorithms, sometimes I don't know the software behavior because she's crossover mutation and evolves in the environment. It's like I say, it's the evolution of species, for example. You have species that get better and better in that environment. For example, you can do genetic algorithms to create new artificial intelligence models. This is common. This is the future. you have, for example, a API named AutoKeras, for example. This API creates neural networks with genetic algorithms. And the better genetic algorithms evolves to get better and better and to learn more. Is something really cool. This.
Nauber, what are the main features of genetic and computer algorithms?
The main features is to choice. The better metaheuristic. Metaheuristic is, for example, you have the sea. You have the sea. You have a fish. You need to how can I say, to teach this fish in the sea. So you can, for example, get a human being and get underwater. So you get choice the environment and choice the agent of this environment. This is so the features, the better features, or the better, like I can say, the better problem that you need to resolve. You need to choose the environment, and choose the better agent for this environment that you play. You cannot get a human being and put underwater and expect that she's evolves for something good. This is not gonna happen. But you can get a fish and got underwater and she's gonna evolve. It's something like that. You need to program in the environment. You need to program in the agent, and to get the agent got in the environment and see the evolution. This is a really good thing.
Nauber, where are genetic and computer algorithms applicable?
Genetic algorithms is applicable today in everything because machine learning and genetic algorithms is how can I say, be a fusion of two things. You have genetic algorithms now create machine learning models. You have auto machine learning. Auto machine learning is use genetic algorithms, for example, to create machine learning models, use evolution. And new is gonna be common now. You have AutoKeras, you have H2O API. You have APIs that create machine learning models using evolutive algorithms. So, for example, you want to go to somewhere. You need to find a better place to go to somewhere. You can use genetic algorithms or evolutive algorithms to cross over the better solution, the better roads that you get to go to your home, for example. In games, everywhere you use genetic algorithms. Everywhere. All player, you evolve the player to fight with you. In common life, so in medicine, you have, for example, I have models that do diagnostic for pneumonia, diagnostic melanoma, and you can use genetic algorithms to improve my machine learning model for that. So this is get more and more common in your lives.
Great. Nauber, was the difference in coding, in programming between genetic algorithms and computer algorithms?
The major difference is the computer algorithms. You know the behavior of the computer. You get lines of code. You know that the program, the computer get the first line of code, so the second line of code, the third line of code, and this. The genetic algorithm is different. You have an environment, you have an agent, you have mutation and crossover. So you don't program each line of code. You program in the environment, you program in the agent, and sometimes you don't know what is happening after that. You put the agent in the environment, and you expect that the agent evolves for something that you want. But sometimes the agent evolves wrong or don't evolve like you want. So you cannot say in evolutive algorithms that the behavior of the software in the training phase, I can say that, is as expected like you want expected. She's evolved for something. For example, you can have many players, and you evolve with this many players. The better player that evolves, you name it Michael Jordan. The worst player, you name it Nauber, for example. I don't play basketball.
Yeah,
I love basketball.
Yeah, I'm as well.
I love basket, but I don't play very well. So the best player is Michael Jordan. The last Nauber. You can evolve these agents and name it this what you want. You get the better. You get the worst. For example, for Immortal Kombat, for example, you have the best player, do fatalities, and you have the lost player. And these are agents that evolve for sometimes in genetic algorithms. So genetic algorithms is very different from common programming for that. You don't need to program. You don't need to program the behavior of the agents. You understand? The behavior of the agent evolves with feedback of the environment. You have a cost function. This cost function guides the agents for the environments.
Oh, a lot of food for thoughts for me. Nauber, so how do you create genetic and computer algorithms? Maybe some main steps.
Main steps. First one, define your environment. Define your environment. Environment, for example, in my PhD, I developed a software to test another softwares. So my environment is the other software, and my tool is to destroy the other two because you want to test the other two how much she's support some load. This way, define the environment is the first thing. The second thing is define the operations that you're gonna do. For example, in genetic algorithms, we do something like genetics. You have crossover. What is crossover? You have genes. These genes, like for example, you have a child. If you have a child, you have genes of you, of your partner, and you have a new genome. So you need to define how these genes will be crossover. So it will be a crossover of these genes, the second task. The third task is to define if you have mutation. Mutation is important. In genetic algorithms, mutation is not a wrong, a bad thing. It's a good thing. Why is a good thing? Because you can receive solutions that you not expected, for example. You can see another solutions for that problem. So mutation maybe are the third thing. The fourth thing is define the cost function. This cost function is something that guide us or guide the agent for the objective. For example, I love chocolate. I love ice cream. For example, you can have a cost function that how much ice cream is better. For example, the player, like say the player of Michael Jordan, how much points she's doing, the cost function is better. So she's evolves to get more points. You understand? You define what is good for this agent, what is bad for this agent in cost function. So environment, mutation, crossover, cost function. These four tasks for genetic algorithms. Genetic algorithm is one algorithm of others that you have evolutive computer. Evolutive computer, you have many and many algorithms. For example, you have sometimes multi-objects algorithms, multiple cost functions. For example, I like ice cream, but I like to see comics. So you have two objective functions. You can see like something like that.
Yeah. So my next question is, how do you create objective functions in genetic and computer algorithms?
You need to define the object, the final goal, of the agent, the final goal. What you want this agent do? What's the final objective of this? She's evolved to this goal. Sometimes she don't evolve to this goal. This happens. But you need to define what the path you want. How I say, you don't code the agent behavior. You expect the agent behavior to try to search the goal of cost function. So the cost function is main, how can I say, is the goal that you do to the agent. The goal that you place in the agent should this evolve like you want, but sometimes does not happen.
Nauber, genetic and computer algorithms have biases.
Yes, genetic and computer algorithms, like machine learning models too, have bias. This is normal. She's had all models, genetic algorithms, machine learning algorithms, artificial intelligence algorithms have bias. She's not, how can I say, have a 100% of accuracy. She has some bias, and you need to treat this bias because it is important. For example, you guarantee that the error, you measure the error of genetic algorithms. This is something important today. For example, you program Michael Jordan in games, but Michael Jordan in games do wrong things too sometimes. So you need to measure this bias and treat this bias. You have bias in all machine learning models. You have bias in genetic algorithms. This is something common in computer science.
Yeah, great. Nauber, what is mutation in computer algorithm?
Mutation is something good in genetic programming or evolutive programming, because if you don't have mutation, the crossover, for example, you have a gene and another gene, you combine this gene and generate a new individual. New individual. This new individual is something like you expected, but mutation.
Sorry, it's in genetic, yeah.
Yes, genetic or
because I am about computer algorithm.
Computer algorithm in general, evolutive algorithm, not only in genetic algorithm, but every evolutive algorithm you can have mutation. For example, you can have mutation for test software. You can have mutation, for example, to mutate the code and verify with this mutation if the code is working yet. So if you mutate the code and the code is continually working, something is wrong with your code because you mutated and its code continues working. So mutation, not only in genetic algorithms, but in computer in general, is important to create new things, to create new evolutive program, for example. You can create new solutions that you do not expected. You can find something new in mutation. Mutation in programming is different in mutation in real world. Mutation in real world in general is a bad thing. It's not X-Men thing, for example. In computer science, mutation for something sometimes is good thing. You can get a solution and mutation that solution to generate other solutions and find a new path for the solution that you try to find, a new way to do something. This is a good thing.
So what's the purpose of mutation in computer algorithm?
The purpose is generate new solutions. Is change your solution to find another solution. Sometimes random. Sometimes a random new solution. Sometimes not. you mutate some genes, some genome, or some code. For example, you can mutate some code to generate another code for your purpose. So you mutate the code to generate a new solution for the problem. Do you understand?
Yeah.
It's a solution that you don't expect it to find it, for example. You can, for example, mutate again to try to find a solution to your problem. This is a good thing. To don't have expected behavior. Sometimes in computer science, you have expected behavior is not good. First, you want to find new things. You want to find, for example, you want to find new treatments for COVID. Sometimes it's better you mutate the solution. You have to get other solution and test if the other solution is good for your problem. Do you understand? You cannot mutate for every time, but sometimes mutate is important. So mutation is change your code, change your gene, change the what you have to create a new one that you're gonna choose.
Nauber, what is a genetic algorithm in soft computing?
Soft computing involves solutions that you not expect the behavior. You don't have a coding behavior. For example, machine learning, fuzzy logic, and evolutive algorithms. So all these solutions, I can say that it's non-determinist solutions. What is non-determinist solutions? It's solutions that you don't have the behavior of solution coded. The behavior of solution is not expected. You don't expect it. You don't know the exact behavior of solution. You need to test. You need to validate. But sometimes if you run your model 2 times, you have 2 results. Sometimes. So soft computing involves logic, fuzzy logic, machine learning models, and genetic program, for example. Is a big category where solutions don't have a code behavior. For example, you have a neural network. You train this neural network, but you don't know, for example, before training this neural network, what is the behavior of this neural network. You need to train this neural network, validate to see if the behavior is what you want, for example.
Nauber, is genetic algorithm machine learning?
No. Genetic algorithm and machine learning is artificial intelligence. The both of things you can say that is machine learning intelligence. But machine learning, how you learn the model, you teach the model, and the model learns what you teach. Genetic algorithm evolves. Evolves in a path that you get a pet. She evolves to get better in this pet, but unnecessary. You teach this model, the genetic algorithms. You don't need to teach a genetic algorithm model. She evolves with crossover, mutation, and a cost function, but you don't need to teach or to get samples to this model. You understand? It's a little difference in this two kind of thing.
Nauber, what is genetic programming in machine learning?
Yes, this is cool. How can I say before? You can use genetic program to evolve, to get a machine learning models and evolve these machine learning models. You get a neural network and create a new one, neural network with mutation, with crossover. AutoKeras, for example, is API for that. You can use AutoKeras to generate new machine learning models, evolve these models, and create new models. This is called auto machine learning. Is the future. You have auto machine learning that learns, evolves, learns again, and evolves, and learns again. This is the future. This is available now. You can go with the Google, put auto ML or auto machine learning, and you have some solution for that. I use these solutions. I use the solution to evolve my models, for example.
Nauber, what are the most famous algorithms you know?
When you talk about evolutionary computer, you have 100 of models. You have many models, but there are some models that I like. For example, genetic algorithm is good. Taboo search get the better individual. Remove the better individual for the population. You have a population of individuals. The taboo search remove this individual. I get another better individual, the second better one. I remove the second better one. I get the third better one. Evolves. For example, you have int column. Int column is very good. You have column of ints, digital ints. The int have a pheromone, a hormone that give the better solution. So you can have an int digital column, and this int digital column find the best path for a problem. Is a bio-inspired model. This bio-inspired model is very good. You have int column. You have another particle simulation. This is genetic algorithms created observing the real world. This is a real good thing.
Nauber, how, in your opinion, how should people put this information in a practice?
You can get for the beginning. you need to start now to programming with genetic algorithms. You can get a API to do that. You can help you you learn something like Python, get API for that. I can later get a sample of APIs you can put in the behind of the video. These APIs you can do programming crossover, mutation, and class function. It's not hard to do that. You can do that. Everybody can do that. It's not so difficult. You need to get an API to help you with that.
Nauber, my extreme pleasure to have practitioners like you on my channel. Thank you so much for joining to us today.
Thank you. I'm very happy to be your channel another time. I am pleasure to talk with you and your audience. So if you need me, I am available.